Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P2649, is specific to the 2006 to 2011 Honda Civic and indicates an issue with the rocker arm oil control solenoid, OCS circuit, specifically high voltage in the solenoid circuit. This component plays a crucial role in the variable valve timing, VVT system, which helps in optimizing engine performance and efficiency. The OCS is responsible for regulating the flow of oil to the rocker arms, which influence valve timing. It is usually located near the top of the engine, connected to the cylinder head. A malfunction can lead to poor engine performance, increased emissions, and issues with engine noise. Understanding this DTC is vital for proper troubleshooting and ensuring the engine runs smoothly. The DTC P2649 signals that there is an excessive voltage in the rocker arm oil control solenoid circuit. This solenoid is integral for the variable valve timing, VVT system, found in the Honda Civic. It manages the distribution of oil to the rocker arms, affecting valve timing and performance. The solenoid is typically found attached to the cylinder head, where it directly interacts with the oil pathways. When the solenoid malfunctions, it can result in insufficient oil flow, leading to various engine performance issues. Therefore, diagnosing this code is imperative to maintaining optimal engine efficiency. There are several potential causes for the DTC P2649 trigger. First, a short-to-power condition in the circuit can lead to high voltage readings, indicating an electrical fault. Secondly, the rocker arm oil control solenoid itself may be faulty, which means that its internal components may be damaged or malfunctioning. Another explanation could be poor connections or loose terminals at the solenoid or the engine control module, ECM. These connection issues can result in signal interference, causing erroneous voltage readings. Identifying the exact cause is essential for proper repairs, as each potential issue needs a different solution. The symptoms of DTC P2649 can manifest in various ways. Primarily, poor engine performance is a common outcome, as the malfunctioning solenoid affects the VVT system's efficiency. As a result, drivers might experience a decrease in acceleration response and overall power. Additionally, increased fuel consumption may occur as the engine struggles to operate efficiently without proper oil flow to the rocker arms. A rough engine idle can also be noted, as erratic valve timing leads to instability in engine operation. Recognizing these symptoms early can prevent further complications and repairs down the road. In the first step of troubleshooting DTC P2649, begin by turning the ignition switch to the on-to position. This action powers up the vehicle's electronic systems without starting the engine, allowing access to the diagnostic functions. Next, it's imperative to record all freeze data and any onboard snapshots. This data can provide crucial insights into what the vehicle's systems were experiencing at the moment the DTC was triggered. By reviewing this information, technicians can pinpoint when the issue began and correlate it with any observed symptoms. Finally, familiarizing oneself with general troubleshooting information specific to the Honda Civic can streamline subsequent diagnostic steps. After recording the necessary diagnostic data in the first step, the next action is to clear the DTC using the Honda Diagnostic System, HDS. The HDS is a specialized tool for Honda vehicles, which allows technicians to read and clear DTCs effectively. Once the DTC is cleared, the technician should prepare to start the engine. This preparatory phase is crucial, as it sets the stage for testing the vehicle's performance under conditions that might reproduce the error. Clearing the DTC allows for a fresh start, ensuring that any subsequent readings reflect the current state of the vehicle components properly. Once the ignition and DTC clearance process is complete, start the engine and hold the engine speed at 3,000 RPM without load. Holding the engine at this specific RPM allows the technician to simulate conditions that may strain the system, testing the solenoid under operational demand. It is essential to keep an eye on the operation of the radiator fan during this period. The fan is designed to activate at a predefined temperature to prevent overheating. Once the radiator fan comes on, the technician can let the engine idle, returning to a normal operating condition. At this stage, it's important to observe any unusual behaviors or sounds from the engine. Following the idle phase, the next step involves checking for pending or confirmed DTCs using the Honda Diagnostic System HDS. This check is crucial in determining whether DTC P2649 is still present after the engine has been run under test conditions. If the DTC reappears, this indicates that there is a persistent issue with the rocker arm oil control solenoid circuit. Conversely, if the DTC does not appear, it may signify an intermittent failure or a momentary problem that resolved itself. Regardless of the outcome, the technician should proceed according to the findings from this diagnostic step. In the fifth step, turn the ignition switch to the lock 0 position to completely power down the vehicle systems. After powering down, disconnect the 2P connector from the rocker arm oil control solenoid. This step is necessary for safely measuring the resistance without the risk of shorting out the system. Using a multimeter, measure the resistance between terminals number 1 and number 2 of the solenoid connector. It is crucial to check that the resistance falls within the specified range of 14 to 30 ohms at room temperature. This measurement determines whether the solenoid itself is functioning correctly. If the resistance is outside this range, then the solenoid may be faulty and require replacement. Following the resistance measurement, the next important diagnostic step involves checking for continuity between rocker arm oil control solenoid 2P connector terminal number 1 and body ground. This test ensures that there is a proper ground connection, which is essential for solenoid functionality. Technicians should use an ohm meter for this test. If continuity exists, it confirms that the circuit is intact. However, if no continuity is detected, there may be an open circuit in the wiring between the solenoid and ground point G101. In this case, further inspection is needed to locate any wiring damage or improper connections that could be causing the issue. In the seventh step, technicians must jump the SCS service check switch line using the Honda Diagnostic System HDS. This action allows for enhanced diagnostic capabilities by rerouting the signal pathways for testing purposes. Next, proceed to disconnect the ECM, specifically connector B, which typically has 44 pins. This step is crucial because it helps to focus on the connections between the ECM and the solenoid. Properly accessing the connector allows for a seamless evaluation of electrical signals and can lead to pinpointing any faults in the communication between the ECM and the rocker arm oil control solenoid. The final troubleshooting step involves checking for continuity between ECM connector terminal B34 and rocker arm oil control solenoid 2P connector terminal number 2. This continuity check is vital for ensuring that the signal transmission between the ECM and the solenoid is functioning as intended. Any discrepancies in continuity may indicate a fault in the circuit, which could range from damaged wiring to poor connections. If continuity is present, it suggests that the communication pathway is intact. Conversely, lack of continuity would require further inspection and potential repair of the wiring or connectors involved in the circuit. Upon completing all troubleshooting steps for DTC P2649, it is crucial to verify that the rocker arm oil control solenoid is operating correctly. This can be done by reconnecting everything and monitoring performance after clearing the DTC with the HDS. Once cleared, retest the system under varying load conditions. The aim is to ensure no malfunction indicators reappear after testing, confirming that the repairs have been successful. If necessary, repeat troubleshooting steps to isolate additional issues. Careful verification guarantees that the initial problem has been fully resolved, preventing future occurrences. Preventive maintenance plays a significant role in mitigating issues like DTC P2649 from arising in the first place. Regular inspections of the rocker arm oil control solenoid connections can help catch loose or corroded terminals before they lead to faults. Monitoring engine performance closely can also provide early warnings of potential issues. Any irregularities should prompt further investigation. Additionally, maintaining the engine oil quality and levels is essential, as poor oil quality can affect solenoid function and overall engine performance. Consistent preventive measures contribute to durability and reliability in Honda Civics. In conclusion, diagnosing DTC P2649 requires a thorough understanding of the rocker arm oil control solenoid's role within the engine's variable valve timing system. By systematically performing electrical tests, including resistance checks and continuity tests, technicians can effectively isolate the fault, making necessary repairs or replacements. Ensuring the solenoid operates correctly is pivotal for restoring optimal engine performance. Remember that preventive maintenance is equally crucial to avoid potential future issues. Following these guidelines will not only remedy the current DTC, but also enhance the long-term reliability of the vehicle. Please like and subscribe to the channel. See you next time.